Hello, good afternoon, or welcome, whatever time it is for you. Welcome to the first human element presentation in this event. The human element is the most represented topic in this program. Excuse me, I have a problem. Sorry about that. I was getting a double image with a Slido on. So the human element is the most represented topic in the program. And it's this range of issues that spread it so broadly across the program. The first presentation is about how to address the human element in design, and our presenter is Richard Fye. Richard is a marine engineer by training. He retired at the end of 2014 as Vice President, Technical Development and Quality Assurance in Carnival Corporate Shipbuilding. He was based in Southampton. He played a major role in the development of the cruise industry over a period of more than 30 years. He remains in the marine industry in a consulting role. Richard is a Fellow of the Royal Academy of Engineering, a Chartered Engineer and a Chartered Marine Engineer. He's a past President and Fellow of the Institute of Marine Engineering, Science and Technology and the current Chair of the Institute Board of Trustees. He's a member of the Lloyd's Registers Ship and Offshore Technical Committees, and he's a Liaison Officer to the Engineering Council. Hand over to Richard.
Well, thank you very much, Jonathan, and welcome everybody. That is the topic of today that Jonathan has introduced. So we'll go on to the next slide. And the Human Element Special Interest Group, as it says on the Nexus link, has as its aims to improve safety and operational efficiency and reduce the risk of operational incidents by educating and informing IMarEST members and all the marine community of the significance of the human element in all aspects of marine engineering, science and technology. And this slide just gives you an overview of the subjects that the group is covering at the moment. And there's a small working group that leads on this topic and aims to deliver the content to members on a regular basis and promote discussion, and this presentation being a part of this outreach. And today's topic is people or human-centered design, which is the light blue circle in the lower left. So what is human-centered design or human factors integration? Well, it's an approach. So remember that it's an approach to designing a system to make it usable with a view to ensuring as far as possible that optimum performance is achieved. And the definition in the applicable ISO standard is as follows. Human-centered design is an approach to interactive systems development that aims to make systems usable and useful by focusing on the users, their needs and requirements, and by applying human factors or ergonomics, usability knowledge and techniques. And this approach enhances effectiveness and efficiency, improves human well-being, user satisfaction, accessibility and sustainability, and counteracts possible adverse effects of use on human health, safety and performance. So all very good stuff. And this approach can be used when designing products, arrangements, integrated system and management procedures and processes. So it's an approach that you can apply across a wide spectrum of issues that we have in the marine sector. So the objective of such an approach, to summarize, is to improve business performance by reducing costs and improving operational efficiency, improve safety by avoiding user discomfort and stress and reducing and hopefully eliminating accidents, and improve sustainability by protecting the environment. And so this is especially important when considering new technologies, which is one of the themes of this conference. And it should form an integral part, of a risk-based approach to the design, testing, commissioning, operating, maintaining, and ultimately disposing of a marine asset. So why is human-centered design or human factors integration important? The answer is if you don't take it into account, then you'll have poor performance and increase the probability of accidents and environmental damage. So perhaps the most recent high-profile accident where usability was raised in an issue were the two fatal crashes of Boeing 737 MAX aircraft before the fleet of all similar aircraft were grounded. So many specialists in ergonomics and human-centered design were very critical of the design approach Boeing had used, and certainly felt that a more rigorous approach to design of the MCAS, that's the Maneuvering Characteristics Augmentation System, including more input from the users, the pilots, was needed. So in the marine sector, we can't be complacent, because whilst in general the number of shipping incidents seems not to be increasing but remaining mainly static over the longer term, the number of serious injuries and fatalities makes it a dangerous sector to be employed in compared to other. Global reporting and collating of information is difficult and incomplete, and so it's hard to quote definitive data. It's especially difficult to get information about injuries and fatalities from smaller coastal vessels and the fishing fleet. But key points produced in March 2014, and this was from a UK based investigation, was that during 2003 to 2012, the fatal accident rate in British merchant shipping, so I stress this is British merchant shipping, was 14.5 per 100,000, and that was 21 times more than that in the general British workforce, 4.7 times that in the construction industry, and 13 times more than that in manufacturing. And human factors predominated over mechanical factors as the main cause of fatal accidents. So it just shows that there's still a long way to go in the marine sector. But the last statement about human factors predominating over mechanical factors as the main cause of the fatal accidents was perhaps not as helpful as it might be, and we'll return to that later on. So why do we have this high accident rate despite shipping being highly regulated? Because on this basis, one would imagine that unwanted events would be relatively rare and outcomes not too serious. However, the demand in the marine industry is very much for prescription and requirements that can be easily understood and enforceable by inspectors and surveyors all around the world, and that create a level playing field for ship owners and operators. Currently, managing risk in the marine world is largely by compliance with prescriptive rules and regulations and insurance. However, and again, this is the theme of this conference, technological development is moving at an ever increasing pace, and it is hard for the regulators to keep pace with this. Goal-based standards are becoming necessary, with risk-based approaches to design being used to demonstrate that the goals will be met. And as mentioned before, a human-centered design approach has to be an integral part of this. Otherwise, unexpected consequences will result when real humans start to interact with the systems. When accidents do occur, many of them are recorded as being owing to, in inverted commas, human factors. Indeed, EMSA, the European Marine Safety Agency, reported that human action represented 65.8% of accident events. In fact, every incident will have a human element to it in some way, since as soon as the human became the dominant species on the planet, it has been building more and more complex systems for its own purposes, and these by definition involve the human. In fact, it would have been more accurate to say that 65.8% of accidents were caused by use error for whatever reason, including poor design, and 100% of accidents were caused by human error. So if we include the etc. above this tapestry of regulations in the slide and requirements, this tapestry of regulations and requirements creates its own problems for the seafarers as they struggle to match them with the systems they're being given to work with. So what is the industry's response? Well, the industry's response to these accidents is generally to blame the human, the seafarer, and to make sure they don't err in the first place or repeat errors of the past, provide them with more and more training and give them more rules, processes and procedures to follow. All this is usually accompanied by lots of forms and check-off lists that need completing. But does this work? Is it just a sticking plaster over a more fundamental problem that ships are not designed well and often are not easily operable and maintainable? Are we trying to fit square solutions into round holes? How many times have you heard it about ships, or indeed many other systems that we interact with in our daily lives? So often you hear, I don't know who designed this, but they clearly didn't know what they were doing. When seafarers are faced with this and frustrated by poor design, they develop workarounds and ad hoc procedures that can lead to very bad outcomes. This is human nature, and as responsible engineers, scientists and technologists, we have to understand this and put the user at the center of what we do and the systems we create. Of course, as a learned society, we need to support our arguments with evidence to support our thesis that we could do better in terms of designing marine platforms. And we have lots of sources of this evidence, and a few of them are listed in this slide. These sources contain a great deal of information that can be used by designers to understand how flawed designs that do not put the user at their heart can result in very poor performance, accidents, and damage to the environment. As Boeing found out in this era of instant communication and social media, there's no hiding place when there's a case to be answered in poor design. So this is a lesson that all of us have to learn. So we mentioned the ISO standards earlier, but there are many marine-specific guides on human-centered design and ergonomics that can be used to not only develop the correct design processes that incorporate human factor integration, but also to provide detailed requirements for many features of ships to reduce the harm and reduce and improve performance. So to all you designers and people looking at ship design, there's a lot of information out there to help you. And in many cases, there's no need to reinvent the wheel. But on the other hand, there's many things to consider, and such guidance needs to be applied with discretion. So is the context of use for your system unique, and does it need special consideration? So if you've designed a marine platform that you think is unique, you need to think about its context of use, and does the guidance that you're using really fit with this? Are your users atypical or are they typical? So you need to, are you applying guidance that was developed by men for men without considering female users? One of the great examples that I heard about this was the Apple iPhone, where its size is designed for the average male hand, not for the female hand, and many female users find it too big to use comfortably. So that's, a typical example of where you've got to think about the context of use and who your users are. So it's not a case of just applying the guidance without thinking, but questioning, and this is important, recording the assumptions made so that they can be tested in the future and feedback can be taken into account. So given that all these standards and guidance have existed for decades, and the science supporting it with anthropomorphic data and ergonomic analysis is understood and accepted, why do we still have many incidents on ships and other marine platforms that can be linked to poor design? There are many reasons, and some are listed on this slide. Some you may agree with, and some you may not, and I'm sure you can perhaps suggest other reasons. In the case of ships, often the argument is that the ship purchaser cannot afford to improve the design offered by the shipyard, but if this leads to poor performance, then simple cost-benefit analysis should reveal the most effective changes to be made, and this will result in a step forward in terms of an improved performance overall. I mean, the well-known saying is, if you can't afford safety, well, try having an accident. So, accidents are very expensive overall, and so a small investment to prevent them can result in large savings. So another aspect about why ship design is important, the recruitment of seafarers is unlikely to become any easier, and so protecting the health and well-being of those that you already have is important. And if you wish to retain them, and this is important if you wish to retain them, and this is in addition to the responsibilities that we have as engineers, scientists, and technologists to prevent avoidable danger to health and safety, and treat all persons fairly and with respect. Clinical depression and suicide amongst seafarers is increasing, so this is a responsibility that we have to take really seriously. And I understand that relationships are complex in the marine world. The diagram on the right shows the stakeholders typically involved in the purchase or modification of an asset and in the operation of a ship or platform. Some of the links between them are stronger than others, and often the users have very little input at the purchase or modification stage when design decisions are made, and that can have a large impact on usability and maintainability. Sometimes there's a design integrator between the asset owner and the shipyard or installer, as is common in the defense and energy sectors. And this makes it even harder for user experience to filter down to influencing the design of the asset being built or modified. But the message remains the same. And if you want an efficient, safely operated ship that protects the environment with a motivated, happy crew with good shore support, and remember this includes the shore support, then you have to give them the tools to do their job well and listen to what they are saying. So to conclude, if you really want to stay on that path of continuous improvement, with or without the introduction of new technology, then a human-centered design approach needs to be applied to what you do. It's common sense, but it also is something that you should be doing as part of your duty of care to the individuals affected by your decisions and for the public benefit as a whole. The Human Element SIG and its associated working group will continue to promote this message through events such as this and carry on raising awareness of the topic whenever it can. Hopefully over time, this will mean that the performance of the marine sector continues to improve for the benefit of all. And so one of our other aspirations is to raise awareness and add this topic to engineering course content, so that hopefully for those coming into the profession, rather than like me coming to the end of my time in the profession, it will gradually begin to change the hearts and minds of those in the industry. So that's very much where I've got to, and thank you very much for listening. So we've got plenty of time for discussion. So I hope we've got some interesting questions coming through, which Jonathan will field. So over to you, Jonathan.
Thank you, Richard. Thank you very much for a detailed and thought-provoking set of slides. They need a lot of study to really understand all the messages you put in there, and there's many years of experience behind what you've said. So thank you very much for thinking carefully about the topic and putting that together. We have a range of questions. Some of them I might group. The first question, which in many ways is the most difficult, but I think it's the one that everyone is now asking, is the STCW convention was revised in both 1995 and 2010. That's 10 years ago. A lot has happened. Do you think it needs to be revised again to take account, to update with the newer technologies that we've seen in the last 10 years? Well, in fact, longer, because of course STCW revisions take a long time. So let's say the last 15 years.
I have to unmute myself first. So, well, there was a revision actually driven by that, which was to introduce standards for the training of electrotechnical officers. So that was in part a response to the introductions of new technologies and the importance of electronic and new electronic and electrical systems, such as the introduction of electric propulsion, or much more electric propulsion in ships. So STCW has been modified to a certain extent to reflect changing technology. But as I said in my slide, the problem is that the pace of change the regulators can't keep up with the pace of change. So we're talking now about new fuels, fuel cells, the hydrogen economy, new fuels. So how are the standards going to keep up with this acceleration of technology? So we go back to those people who are designing these ships have to take into account who is going to use this new technology, not wait until new regulations come along and hope that then the training will come along. They've got to think about the people who are going to be using it when it's introduced, and think for themselves and not rely on this regulation when they're designing the ships and the systems, these new technologies. So to actually take ownership of the challenges that the users, the seafarers, are going to face.
Yes, and of course it's not just the navigating of the ship and the platform, it's also the new cargo technologies and the new environmental technologies to be introduced.
It's the whole ship.
Yeah, the whole ship, and even the ship and the shore. Right, we're getting a lot of votes for two questions, and they go in very different directions. They're both deep and thoughtful questions. The first one is, and I'd like to generalize it a bit from the way it's stated. It's stated, how do you think the use of past case studies of maritime incidents, marine incidents, can best be replaced when designing for low carbon vessels with a lot of new technology? Now, I'd like to generalize that away from low carbon to new technology. But the point that I think is behind the question is, if we have new technologies, new ways of operating, in many ways a new context, how relevant are past case studies and marine incidents to the new situation? And how could they be replaced? What else could we do to design for new technologies if the experience of previous incidents is now not as relevant as it used to be and used to be the driver for all HUMA regulation?
Okay, I think I can answer that. So the past cases are relevant, but it's true to say that when you get new technologies and leaps forward, then maybe you need different techniques. So here I can speak from experience in that I was fortunate enough to be involved in the design of the Grand Princess, which at the time was the largest cruise ship in the world. So the senior management recognized that we were kind of leaping into the unknown because nobody had ever built a ship this big before. So what we did was that we adopted a risk-based approach to try and identify the hazards that might be that might come to light with operating a ship this large. And we used outside consultants to help us, one of which was, as it was then, AEA Technology, which was a spin-off from the UK Atomic Energy Authority. And indeed, Lloyd's Register of Shipping also assisted through the shipyard with a full risk-based study of this ship design because it was unique. So we also involved the users in that hazard identification process. So we involved chief engineers, deck officers, superintendents, so that the facilitators were able to draw upon a vast background of knowledge and experience to try and draw out what these hazards could be with operating this unique size ship and the systems that went with it. So yes, there are techniques that can be applied to doing this, and the user, or the potential users and the past users of the older systems are very important in involving them in this in these techniques.
Using the cycle of activities that you described earlier.
Yes. Yes.
Yeah. Right. Martin Shaw's asked, how do we get investigations to look into human error in the design of ships and equipment and management processes to prevent accidents? Let me put emphasis into that. How do we get investigations to look into human error in the design of ships and the management processes in order to prevent accidents?
Well, it goes back to the awareness. We have to make sure that the investigators from the flag states that are responsible for these investigations are aware of and are searching out for possible design problems in ships. So, that does happen. There was the famous case of the ship which had the aerodynamic rounded bridge, where people didn't really know which window they were looking out of, and the divisions between the windows obstructed the view of the navigators. So that a design fault was discovered as part of the investigation. So it is possible for this to happen. But again, part of this outreach, if there are investigators out there listening, is to make them aware of possible design faults that were a precursor to the problems that the ship or the marine platform encountered.
And the other part of the question was about management process, the contribution of management process to incidents.
I think it starts a long way before the incident. I think it starts right at the beginning. So as I say, I was fortunate in the projects that I worked on mainly that I had a management who was aware of the problems that could arise if you didn't take into account the user, and especially if you were designing something that was unique or that was pushing back technological boundaries. And so you need that buy-in from the senior management to understand the risk to the business that if you don't do this. And I think so that the management of the approach needs to start right at the beginning. So the management of the company needs to buy into the approach and understand that a risk-based approach, a human-centered design approach, is the best way to manage your risk, and just ensuring it and compliance with prescriptive regulations will eventually come to bite you. So that's my answer to management. It needs to start right at the beginning. It needs to be a cultural change. As I said in my last slide, it's a hearts and minds issue.
And it needs to carry on right through operation and not stop at the day the ship's delivered.
Yeah, yeah.
Right, we've now got a collection of questions which I think can be grouped together. They are going from the bottom. If the human factor is the weak point, in fact, so what is your view on whether further automation will cause more accidents than prevents? We've seen various accidents caused by autonomous systems not operating as expected. Then we've got, is the human factor the weak point? Should we be pushing for the removal of the human from the loop in all aspects of design, build, operation, disposal? And at the top of the list with the most votes, how far do you think that technological solutions can mitigate human error? So I would what I would do is treat the first three as context. We're seeing higher degrees of technology being proposed as a solution to human error, to improved health and safety, and to smoother operation. And we're seeing, as you've said already, many new technological solutions. What's the relationship between new technology and human error?
I would answer probably, I mean, of course, advances in technology have been fantastic. If we talk about healthcare, communication, you know, just the standard of living for the vast majority of people on the planet has been improved by technology. So we can't just be say as a blanket statement that technological development is bad. That would not be the right thing to say. Technology has helped a lot to improve human health and happiness, but obviously a lot of companies want to use it to improve efficiency as well. And what they've got to look out for is the unintended consequence. And you can only look out for that if you understand the human and the human who's going to use this technology. So, and the human factor will always be there, even if we have unmanned ships, because some human will be developing the software. They might be a human in a shore office monitoring the progress of the ship. There'll be a human who will need to maintain that autonomous ship. So user-centered design will always be necessary. The user, in inverted commas, might change. The role might change from, it might be a maintainer rather than an operator, but there will still be a human factor involved, whatever the technological development. I'm not sure I've answered the question very well there, Jonathan, but
I think you have. I think you have. It's speaking. Go. Yes. going back to the main point, which is understanding who is using something is important, whatever it is, and however it's designed, whatever the technology is.
Yeah.
We've got two questions which I think very closely relate to that, and together they score 5 points. That's quite a lot. So Ifobilaki has asked, as ships tend to be prototypes much of the time, how does the design process remain robust, as each ship will have a different manufacturer and design team? Remember that. The other one is Bob Doncom asks, is the real answer to provide better design processes instead of regulation? Tools invariably get smoother acceptance than hurdles to jump in his experience. So I think the two together say, should we be trying to require a design process rather than regulate in a more prescriptive fashion?
Oh, well, the answer to the second one is easy, yes. I mean, as I said, my experience with using a risk-based design process was that it was very successful. It showed flaws in the design of the ship that if we just followed prescriptive rules or copied the last ship, wouldn't have resulted in a suboptimal outlook. So yes, they are techniques that can be used, and I would urge people to think about that and look at that. The small number of models of any one ship that you build is an issue, but actually the iteration is not that fast. So the first time you adopted a different design process, such as a risk-based design approach, it takes quite a long time, and you develop a lot of information and a framework. But then when the next ship comes along, you've already done that work. So you've changed something. So you've got to think about, you've got to go back to your original study and say, what's changed? What are the things that I've got to be careful about when I've got this new ship, that it's still a bulk carrier, but it's slightly different. It might be bigger, or I've put a different fuel on board or something like that. If you know that the issues, the hatch covers are going to be the same, and you've already done your risk-based approach to the design of the hatch covers, then you don't necessarily need to do that again unless there's been a different to the trading pattern or something. So you just need this awareness, but there should be less work to do on the follow-on designs. That would be how I would look at it.
Yes, thank you. So question at the top now is, what is the difference between training and human-centered design? That speaks probably to the STCW question at the beginning.
Well, you clearly need training, because if you have a new bridge equipment or something like that, you will hope that it will have been user-centered design, so that a person operating it will feel comfortable that he or she knows what they're doing. But you still need some training. You still need to show them the features of that particular user interface. So there will still be training necessary, but the purpose of today's talk is to show that you can still get use error if the design is poor. So however good the training is, if the design is poor, you will still get use errors, and that will give you these unintended consequences.
Thank you. Slightly different direction now. If the accident rate is so high in the UK, how much worse do you think it is in other countries? And how do we deal with fishing vessels? Going back to your slide on the justification in terms of accidents, in terms of what you're talking about.
Yeah, I mean, the problem with the whole of the marine industry, which has been well reported, is that it's impossible or virtually impossible or is impossible to collect global statistics on accidents and fatalities. So the Seafarer International Research Centre at the University of Cardiff has been trying for perhaps over a decade now to collect statistics on global accidents, and has found it very, very difficult. So it can only extrapolate from the data it has. And yes, unfortunately, it's probably not a very nice picture. So, and fishing vessels, yes, do represent, as the Maritime and Coast Guard Agency in the UK has reported, fishing vessels have a very high rate of accidents and fatalities. And the Maritime and Coast Guard Agency's approach, which is to be commended, is to get around there and educate the fishermen on the risks and try and get them to change their behavior and to make sure that the risk, as far as possible, is minimized. Fishing is a very dangerous industry.
It's a fundamentally dangerous thing to do. Yeah. So another question in a slightly different direction again, positive one. If you could wave a magic wand and make one change that would reduce accidents, what would you change?
If I could wave my magic wand and want to change that would change. Yeah, I don't think you can answer that. I don't think there is a magic bullet. I think it's looking at the ship design as a whole and looking at all the components that make up that ship design, because they all interact with each other. So you can't just change one thing and say it will improve. You have to look at the ship as a whole, as a system, and take your risk-based approach to that whole system, which is the ship and all its different modes of operation, its context of use, etc., etc. So I'm going to dodge that one and say that there isn't a one single thing you can change.
There is no silver bullet.
There is no silver bullet. No, I'm afraid not.
But here's suggestions now and questions. First suggestion is, would championing excellence in human-centered design help in raising awareness of best practice? Have some form of recognition scheme, maybe?
Absolutely, absolutely. And one of the ambitions, I think, Jonathan and I raised this issue with the University of Southampton, and on their ship science course now, the human-centered design, the human element, is becoming more of a feature of that course than it was in the past. So if the students do a project, for example, on a ship design or a part of a ship, then they are encouraged to think about the user and how the user and the maintainer would, and the person who has to ultimately dispose of it, would interact with that design. So that is part of the awareness. And yes, hopefully courses like that will become beacons of excellence because they are embracing this topic.
Thank you. Now I've got 5 questions, all with the same weighting. Trying to work, what I'll do, I'll ask the one which may not be related to the others. No, I'll tell you what, here's a really difficult one. The actual crew of the ship is identified after construction is almost at completion. How do we close the gap between design, construction, and operations in that case?
So the owner of the asset who's contracting the ship presumably has some way of determining who the users of that asset is going to be, and of course you have leave cycles and all the rest of it. So in an ideal world you consult with all of them, but that's impossible. So you have to make sure that you consult with a cross section of users that you think represent the typical user, but at the same time bearing in mind that they may be atypical users as well. So that's important. So it comes back to this awareness issue, this awareness of the different users that you have, and how can you make the design robust and what's the right word? Design it in such a way that a broad spectrum of users can use it safely. So that's another part of the challenge, is making that your user-centered design is usable for a broad spectrum of users, not for a very narrow spectrum of users.
We're seeing that requirement now coming into regulation out with shipping under titles like universal design and design for all. And of course that will help with retention as well, and potentially help with recruitment of the widest pool of people who want to go to sea.
Yes.
In your diagram, it was the upper circle of users and use, which is poorly connected into the industry. And there are ways being found to make that connection better.
So how the aircraft industry addressed that was by having a standard cockpit. So an Airbus has the same cockpit, so a pilot doesn't have to fly the same aeroplane every day. He can move from one Airbus or a type of Airbus to another type of Airbus, and he's not flying the same aeroplane every day because they have that level of standardization. But of course, in the marine world, standardization is a dirty word, because owners or asset purchasers generally don't like standardization, because it gives one or two manufacturers a monopoly that they can use to increase the price of their products. So standardization has never been seen as a route to improving usability in the marine world.
We've got 4 questions, one with 2 votes, and it could be usefully discussed. So I'm going to give you the opportunity. I'm going to ask for 1-word answers for the other 3 questions. Okay. It's a quick fire round. Is it a risk that designers and builders sometimes refrain from pushing new methods and technology as it is easier to qualify a system that's previously been passed?
Passed by who, though?
Well, class presumably, or regulator.
Well,
or an owner.
My argument would be, yes, it's a risk if it hasn't been validated by user experience.
The next one up from the bottom: should the design process be forced to consult with educators to ensure the base knowledge required to operate new equipment, rather than just as an afterthought?
Should educators be?
Yes, I think what it's saying is, should you communicate with the educators early in design to make sure you understand what people actually know, rather than give the product to educators at the end and say, teach this?
Yes, because a trainer is in a way part of the chain to the user who's going to operate the equipment. So they're a stakeholder in the process, aren't they? They're a stakeholder in the whole asset. So of course, yes, they should be consulted.
And then there's an observation, I think, with respect to defence, there are now requirements to include operators in safety and environmental studies. And then there's an aside saying there are always areas to improve. So in defence, some of what you're saying is required, a fundamental risk-based approach and involvement of operators in studies is already there. And then the question which we could carry over 4 minutes to discuss is, humans may excel at dealing with the unpredictable, while algorithms could be much better at dealing with repetitive tasks. How can we benefit from this?
Right, I would answer that. So I've read a really interesting article recently about driverless cars. So 10, 15 years ago, driverless cars were going to be on the road within 5-7 years. And we now nearly 2 decades along the path. And some companies are now bailing out of the driverless car initiative. So I wouldn't get too excited about algorithms taking over. It's not in the immediate future, because it's obviously proven much harder to develop in the car market than it has, than probably people anticipated. That would be my answer to that. Don't hang your hat on algorithms. The marine environment is infinitely complex and hostile. So I wonder if it will take quite a long time to develop robust algorithms, in the same way that the car industry is finding it extremely difficult as well.
We've got and there's a final question just popped in. I think it's someone with inside knowledge. You have an interesting presentation. Good, thank you. 100 point extra bonus points if you can tell us if the Crown Princess has a seat for the helmsman.
Which Crown Princess? Well, if it's the latest one, yes, it will have a seat for the helmsman. Well, it doesn't really have a helmsman anymore now. You have a little joystick and the officer of the watch can steer the ship. And yes, he does have a seat.
Right, and that's pretty well exactly the hour. So thank you very much indeed, Richard. It's a really interesting presentation, and both the presentation and the questions. And thanks for all your effort and continuing support in your supposed retirement.
Well, thank you to all the people who watched and listened in, and for all their questions. There were certainly some challenging ones, but I hope I answered truthfully, and it was interesting.
Thank you. Now we hand back to Ches to close for us.
Yes, indeed.
Thank you both, and thank everybody for watching this webinar. It will be available to watch on demand after we have finished streaming. Please do continue taking part in the conference, and you can continue your questions on the timeline. And thank you once again to the Bangladesh Marine Academy, sponsors of our Human Element stream. Goodbye.